Hey everyone, it's Bradley Bush with another algebra video for you. Today we're talking about solving equations with rational exponents. If this is your first time to my channel, thanks for coming. If you're returning, thanks so much for coming back. I appreciate it. Hope you enjoy the video. If you do, please consider subscribing, leaving a comment, or giving me a thumbs up. Equations with rational exponents. Well, we know from algebra rules that rational exponents represent radicals. Radicals are those roots like square roots, cubed roots, fourth roots, and so on. A rational exponent is just a fractional exponent, and we know that the denominator in that fraction is the index on the radical. So, and the top, the numerator, is the power. So you can see the numerator here is the power on the variable. So we can switch back and forth between rational exponent notation and radical notation. So when we're solving equations with rational exponents, we know it's going to involve radicals in some form. And if we happen to have an equation of the form x raised to a fractional exponent a over b equals some constant c, where c is a real number and a and b are both positive integers, then we can use this simple step-by-step process here to solve for x. The first thing we want to do, our step one, is we want to isolate the term with the rational exponent, meaning get it by itself. So it has to fit this form that you see highlighted in yellow. X to the some fractional exponent equals some constant. Then once we have isolated the rational exponent, then we raise both sides of the equation to the reciprocal of the exponent. So the exponent is a over b. So b over a is just flipped. The bottom is in the top, and the top's in the bottom. So for example, if a is even, meaning the number that's in the top, a, the numerator, if that's an even number, then we flip the a over b and it becomes b over a. And you can see that we are raising both sides to that same power. And on the right side, we add a plus or minus. And we have a cancellation of that a and the b and the exponents on the left. And we're just left with x on the left, and it gives us plus or minus c raised to the b over a. If a is odd, then we follow the same process, but we don't have the plus or minus because there's just one answer if we have an odd indexed radical. So the answer would just be x equals c raised to the b over a rather than plus or minus c raised to the b over a. And finally, the last step is we would need to check all of our answers to make sure that they were in the domain of the problem and they were not extraneous, meaning they weren't fake answers that we introduced because of how we solved the problem. Let's solve one of these. Here's an example. We have 3 times x raised to the 3/4 power minus 6 equals 0. So let's isolate the term with the radical. So we're going to add 6 to both sides. That cancels the 6 on the left, and we get 3x to the 3/4 equals 6. We can divide both sides by 3, and we get 3's canceling, and we get x to the 3/4 equals 2. Now, we flip the exponent, right? So we raise this to the 4/3 on both sides. And you can see the 4's and the 3's cancel each other because we multiply straight across when we're multiplying, or when we have a power raised to a value raised to a power, all raised to another power. We multiply the exponents. So we get 12 over 12, which is just 1. In other words, let me write that over here. just to make sure that you are understanding what I'm saying here. So we have x to the 3/4, all to the 4/3. When we simplify this using our exponent rules, we get x to the 3 times 4, which is 12, over 4 times 3, which is 12. That's just the same thing as x to the 1, which is just x. So in other words, they cancel each other out. So that's why we chose to flip the power and then raise both sides to that flipped power. So we end up getting x equals 2 to the 4 divided by 3. We could keep writing this. We could finish and say, yep, there's our answer. But we could keep simplifying this and put it back into radical form if we wanted. This would be 2 to the 4th power, which is 16. And then we'd have the 3rd root of 16. You could also write that if you wanted. Now we want to check our answer to make sure it's a valid answer. So we take it and plug it back into the original. The original is, so we're checking first, x equals 2 to the 4/3. And the original was 3, and then we have x. Instead of having x, we're going to write 2 to the 4/3. And that is raised to the 3/4 minus 6 equals 0. We get 3 to the, we notice that we have some canceling with the powers there, and we just get 2. So we get 3 times 2 minus 6 equals 0. 6 minus 6 equals 0. 0 equals 0. There we go. We just verified that that was an actual solution, so we're good to go. 2 to the 4/3 is a valid solution to this problem. Let's do another one. Here's another one. Example B is x to the 2/3 power, and then we have minus 8 equals -4. So let's get it to the correct form. So we need to isolate the term with the radical. That 8 is terrible. We get x to the 2/3 equals 4. And now we can flip the powers. So we get 3/2. We raise both sides to the 3/2 power. After we raise both sides to the 3/2 power, we can see we have some canceling going on right in the powers. And we get x equals 4 to the 3/2. But we need plus or minus because we had a 2 in the denominator and 2 was even. So remember, when the denominator or the radical is even, then we have to add the plus or minus. When it's odd, we don't. All right, so we get x equals, well, what is 4 to the 3/2 power? The 2 on the bottom means take the square root. So let's take the square root of 4. So we have plus or minus square root of 4. And that's cubed. So we have plus or minus square root of 4 is 2 cubed, which gives us plus or minus 8. So I need to check both of them and make sure they work. So let's do that. Let's do x equals -8 first. So we have -8 to the 2/3 power minus 8 equals -4. So -8 to the 2/3 power, what does that give us? -8, if we take the cube root first, that gives us negative 2. Negative 2 squared is 4. 4 minus 8 equals negative 4, and 4 minus 8 does equal negative 4. So negative 4 equals negative 4. That's a valid solution. Let's check the second one. So we check x equals positive 8. So we have 8 raised to the 2/3 minus 8 equals negative 4. 8 to the 2/3, that gives us, if we take the cubed root first, the denominator first, the cubed root of 8 is 2, and 2 squared is 4. Minus 8 equals negative 4. 4 minus 8 is negative 4. Negative 4 does equal negative 4. That one works as well. So both of those are answers. So x equals plus or minus 8. Those are both valid solutions to this problem. Whoop. Let's try another one. So this looks a little bit different, right? We don't just have x raised to some power, but we do have just some quantity raised to a power. That's a fractional power. So it still fits the form. So we can just start by what we did before and flip here. Flip the exponent and raise both sides of the equation to that flipped exponent. And because we're taking the square root of both sides, which is seen by the 2 in the denominator, we need to add the plus or minus. On the left, we have canceling of the 2's and of the 3's in the fractional exponents. We're just left with x plus 5 equals plus or minus 4 raised to the 3/2 power. What is 4 raised to the 3/2 power? I think we just did that in our last example. The square root, the 2 in the bottom, the square root of 4 is 2, and 2 cubed is 8. So this is really x plus 5 equals plus or minus 8. So let's do both options. So option 1 is the plus, so we have x plus 5 equals positive 8. If we subtract 5 from both sides, we get x equals 3. That's one option. Option 2 is the negative 1. So x plus 5 minus 8. If we subtract 5 on both sides, we get x equals negative 13. Let's check both of those to make sure they're both valid solutions. So we plug it into the original. So we have x we'll start with x equals 3. So original is 3 plus 5 to the 2/3 equals 4. So 8 and to the 2/3. That does give us 4, actually. 8, if we take the cube root of 8, that gives us 2. 2 squared is 4. So that one is a valid answer. Let's try x equals 13. Negative 13. We get negative 13 plus 5, 2/3 equals 4. Well, negative 8 to the 2/3. The cube root of negative 8 is negative 2. And negative 2 quantity squared is 4. So 4 equals 4. That's also a valid solution. So both 3 and negative 13 are valid solutions to this problem. Let's try our last one. Our last one looks even a little crazy, even just a little bit crazier here, because we have a quadratic, and that's raised to a power. But let's get everything that's inside the term. Let's just get the term with the rational exponent. Let's get it by itself. and everything to the other side. So let's add 2 to both sides, which cancels the 2 on the left. And we have this quadratic. I should probably tell you what we were working with to begin with. So the original problem was quantity x squared minus x minus 4, all raised to the 3/4 power. And then we have minus 2, and then that equals 6. That was the original. We took the negative 2 to the right side, and 6 plus 2 gave us 8. So now we have that quadratic raised to the 3/4 power equals 8. And we can start by flipping. And now we're taking everything to the 4/3 power. And because 3 in the denominator is odd, we don't have to add the plus or the minus. We can see, though, that we have some canceling of the powers, and we just get x squared minus x minus 4 equals the cube root of 8 is 2, and 2 to the 4th power is 16. We get x squared minus x minus 20 equals 0. We've got to factor this into two things that multiply together to give us negative 20 and sum to give negative 1. So that's how about x and minus 5 and x plus 4. And then we solve we set both of those equations equal to 0 and solve both of these factors, x minus 5 equals 0. So that means x equals 5. And x plus 4 equals 0. So that means x equals, if we take 4 to the right side, it becomes negative. And we have x equals negative 4. So those are the two options, and we need to check both of those. Let's check x equals 5 first. So we have 5 squared minus 5 minus 4. That's all to the 3/4 power. Minus 2, that's got to equal 6. So we have 25 minus 9 to the 3/4 power. That is 16 to the 3/4 power. Minus 2 equals 6. The 4th root of 16 is 2. 2 cubed. So that gives us 2 cubed minus 2 equals 6. 2 cubed is 8. Minus 2 equals 6, which is 6 equals 6. That one is a valid answer. Let's check our next one. That's kind of a long checking process there. Now let's check x equals negative 4. So we have negative 4 squared minus 4 minus 4 all to the 3/4 power minus 2 equals 6. Negative 4 squared 16. Negative 4 is positive 4, and then we have minus 4. Luckily those cancel each other out, right? We have 3/4 power minus 2 equals 6. We can see the 4 and the negative 4 cancel each other out. 16 to the 3/4 power minus 2 has got to equal 6. 16 to the 3/4 power, the 4th root, the 4 in the denominator means it's a root, so the 4th root of 16 is 2. 2 cubed is 8. Minus 2 equals 6, which gives us 6 equals 6. And that's a valid solution as well. So we just showed that both x equals 5 and x equals negative 4 are both valid solutions to our problem. That's it. Hopefully this was helpful. Hope you learned a little bit about how to solve equations with rational exponents, and hope you have a great day.